with Toni Nadal from Park Towley University Hospital, who's going to talk to us about personalized surgical process for joint replacements. Toni, thanks for joining us.
Hi, everybody.
Hi, you have 10 minutes. We'd love to hear about about your case study.
Okay, thank you.
Over to you.
Next slide, please. Okay. First of all, hi, my name is Toni Nadal, and I'm the coordinator of the 3D lab at the Park Towley Hospital. First of all, I wanted to start by thanking EcoQUIP team for giving me the opportunity to be here and also for all the support obtained. Without them, this wouldn't have been possible. Today, I'm going to talk about personalized surgical process for the joint replacements project. This project started from the orthopedics unit within the Park Towley Hospital, a hospital center with a large volume of surgical treatments. To develop the project, the 3D lab has coordinated with the Park Towley Innovation Institute, ITRESPT, and AQUAS, a public entity with the mission to generate healthcare scientific and relevant knowledge to improve safety and sustainability. A big shout out to everyone who has participated in the project. It has been a long, hard work, but it has been worth it. So worth it, as you will see, that a little 3D printing lab has evolved to a new transversal unit for the hospital called digital surgery. Next slide, please. First of all, I will start by explaining the problem that was detected. Reparative surgeries are very complex since they not only require placing a prosthesis, but also removing the previous one that has failed. When the prosthesis is removed, the bone and the zip cones are much more damaged, making it more difficult to place the new prosthesis. It must be taken into account that currently the most common thing is to use standard prostheses that have certain pre-stabilized sizes. That is, in this traditional method, the patient must adapt to the existing prosthesis and not the other way around. We must also take into account the factor of placing the prosthesis freehand, which can generate small deviations. If the prosthesis must last from 15 to 20 years, having only a small difference, like millimeters, on the length of the result is going to cause great stress in the long term. Next slide. In prosthetic surgeries, the traditional method contains a series of details that make the process not optimal. On one hand, we must think that since it isn't known which prosthesis is going to be used, especially when it is a reintervention, the surgeon needs to bring all the tools and prosthesis sizes to the operation room, just in case he's going to need them. In the picture, you can see an example of a set of several boxes with the equipment for a surgery. But depending on the surgery, there can be more boxes. From a sterilization point of view, needing all the equipment means that you have to sterilize several boxes of surgical instruments each time, just in case. This means that a large amount of instruments are being sterilized with the environment and resource impact that entails. Next. The starting point was to try to make 3D printed personalized prostheses. By making custom prostheses, we could reduce the amount of instruments to be sterilized and also adapt the prosthesis to the patient, reducing the possibility of reinterventions. Next. The first and most important thing from my point of view was planning the surgery. To do this, we need to create a digital twin and perform the surgery from the computer. This would allow us to reduce improvisation, take measurements, and have expectations about the results of the surgery. In the end, we wanted to simulate the surgery, but without having to be in an operation room. On the other hand, we needed to have access to manufacturing in a very agile way. If custom-made objects take a long time to reach the hospital, this solution will not be applicable to many surgeries and, above all, will not be scalable. Creating health products means having to control and record all the processes carried out to comply with regulation. When it's something personalized, it is more important, since that piece is unique. Ensuring the traceability and the registration of all processes will be very useful to be able to have indicators to analyze and evaluate profitability. In the end, for this type of solutions to make sense, it must be able to be applied from a functional but also economic point of view. For this reason, we defined the following needs to be met. We needed to personalize the surgery, but in such a way that it could be scaled up and become a new standard way of working. To do this, we must be agile, fast, and above all, safe, complying with all the necessary security measures. Next. Therefore, our requirement translates into moving from a traditional workflow to a customized one. Here you can see the traditional workflow where most of the decisions are made in the operation room itself. Next. For modifying the workflow, it was necessary to include several more phases in the surgical process. First of all, we needed to create a digital twin of the patient. Then we had to manufacture all the necessary instruments with all the regulatory, traceability, and registrations to finally obtain a kit or a closed solutions to carry out a personalized surgical process. In this way, when planning the surgery, we sought to bring the minimal possible instruments to the operation room to reduce the surgery use time as much as possible. Next. To continue this ambitious mission, we carried out a market consultation and listened to our stakeholders. To develop our project, we needed several industrial tools and solutions that were not initially intended to be applied in surgeries. This complicated the project since several parties had to agree and work together. Once all parties were heard and the real solution was analyzed, we were able to put out a tender for the project, which, at least for us, has required a lot of effort and work, much more than expected. We must also keep in mind that the idea was to go to the market in a very open way to be able to adapt and understand all the parts. This is theoretically very nice, but a lot of constant work. Next. In the end, as in all projects, not everything is as one imagines. Situations and things change, making you pivot. We finally saw that the best solution was to end up being manufacturers of health products ourselves. That was a paradigm shift, since by being the manufacturers, we could be much more agile and efficient. But on the other hand, the workload of records and process traceability increased significantly, really a lot. Another thing we learned is that there are manufacturing techniques that did not make sense to have inside the lab itself, such as 3D printing in metals. But we have seen that the applicability of surgical planning is so great that many of the interventions do not require personalized implant, but do require planning and surgical guides. Finally, we put out a tender that was a combination of equipment and software from different suppliers, medical and also industrial. The solution had to be integrated into the lab processes and work in harmony. Next. Therefore, we had to require all kinds of new tools. We are very happy to have been able to extrapolate this initial idea into a transversal project, not only designed for knee reintervention surgeries, but for all types of surgeries, whether or not they are reinterventional or knee surgeries. This approach has allowed us to understand the entire process much better and open our eyes to new applications. Personalized treatments are a reality and must be promoted to become a standard process. Now we are starting to compile the indicators to analyze the results, but we have already seen that we are much more versatile when it comes to making personalized cases, much more agile in manufacturing, and above all, more robust, safer, and faster in the regulatory area. Next. Here you can see the tools integrated in the 3D lab. Now we can simulate surgeries on the computer with engineering tools, but also maintaining the traceability and recording of all actions and processes in a much more efficient way. Also, an improvement has been incorporated in the communication system to coordinate planning with the doctor. In this way, we are much more efficient when designing a personal case, allowing us to make all types of surgical plans. We are also capable of manufacturing tools with biocompatible materials or 3D scanners to be able to digitalize in a non-invasive way. Next. In conclusion, we are very happy with the projection of the project and the applicability it's having. Many different profiles have agreed to be able to do this. We have created value in several aspects, and we have a solution with a very promising future. It's very important to highlight that the business ecosystem has also been improved. Several industrial companies have expanded their market by approaching the healthcare world. This is not only good for companies, but also for medicine, since it allows to expand the range of available solutions. A great indicator of the importance of this project is that now the 3D lab has become a medical unit. Just as there is a radiology unit, there is now a digital surgery unit, in which interventions are planned and personalized health products are manufactured. It is still early to get definitive results, but by planning surgeries and working with personalized instruments, more precise surgical results are obtained. Interventions last less. There is more control of all processes and complications are reduced. This translates into a reduction in time in the operation room and a better use of resources, making us more sustainable and efficient. We believe that we are facing the new surgery, personalized treatments that are more efficient in results and use of resources. Next. I recommend bringing the final report because there are much more details of our experience. Thank you all.